Okay, Gabrielle, so we have the problem x times x minus 1 all over x plus 4 x minus 3. Just wanted to make sure that was the correct problem. So if we multiply out the top, you're going to get x squared minus x all over x plus 4 x minus 3. And the first step that you have to do in fraction decomposition is look at the value of the degree for the numerator and the denominator. Since the numerator is x squared and the denominator is x squared, anytime that the numerator has the same degree or a degree higher than the bottom fraction, we have to do long division first. So I'm hoping that you remember how to do polynomial long division. So I'm just going to show you right here. So what we have to do is divide the denominator into the numerator. So if we multiply out x plus 4 times x minus 3, we're going to get x squared plus 4x minus 3x minus 12. And then you combine like terms, so we get x squared plus x minus 12. So we're going to divide x squared. Go over here. Sorry. This ain't the best video, but x squared minus x minus 12, and we're going to divide it into our numerator x squared minus x. So anytime that you see in fraction decomposition that the numerator is an equal or greater degree, you have to do this step first. Okay, so that's probably why this problem was difficult, because they didn't say that. So we're going to do x squared into x squared, and that goes one time, and then 1 times x squared is x squared. 1 times negative x. Oh, actually that should be a positive x, because positive 4x minus 3x is positive x. So sorry about that, positive x here. And then 1 times positive x is plus x, and then 1 times negative 12 is negative 12. And then we're going to subtract. So it's, if you forgot how to do long division with polynomials, it's just the same steps. You just multiply you divide the x squared into the x squared, and then you're doing like the subtraction and bring down, okay? So if we subtract, we get 0 here, and then negative x minus x is negative 2x, and 0 minus a negative 12, which goes to a plus because it's 2 negatives, will be plus 12. So then now we have a fraction that is an improper fraction, which is now 1 plus, we put what we got for our answers, so it's negative 2 x plus 12 all over our dividend, which if we, this is what it was in the beginning, so then we'll put that as our fraction. Now, this matches the answer that you gave me, but I just kind of wanted to take it a step further and show you how to do it further, because we still, now we have a numerator that has a lower degree than the denominator, so we can do what you were doing from the beginning. And I watched a YouTube video of somebody else that was teaching it, and I like the way that they did it better, so I'm going to show you that way, okay? So we have now negative 2x plus 12 all over x plus 4 x minus 3 is equal to a over x plus 4 plus b over x minus 3. Okay, so now this is like the original step, and it's an and you should be able to understand how to do it because you were telling me how you were doing it the first time, which was absolutely correct. I think the only thing that threw us off in this problem is that we have to do that original long division first, okay? So now we're going to multiply both sides. This is kind of where it differs than how your teacher was teaching it. So you pick which way you like better, but I'm going to show you this way because I did kind of like it. But what you're going to do is multiply both sides by the denominator. So we're going to multiply both sides by x plus 4, x minus 3. And this side, x plus 4, x minus 3. Okay, so on this side, the denominators just cancel. So we have negative 2x plus 12 equals, and then if we multiply this side, the x plus 4s will minus out. So you'll get, the x plus 4s will cross out. So you'll get a times x minus 3 plus b times x plus 4, because both of them will cross out from the denominators, which is kind of where you were at, okay? And then now we're going to plug in a value for x, and the value that you plug in, you want to make one of these equal to 0. So the first one I'm going to plug in is let's let x equal 3, because that will make this 0, and it will make the a go away. So I'm going to say let x equal 3. See? And so I'm going to plug in 3 for all of my x's. So negative 2 times 3 plus 12 equals a 3 minus 3 plus b 3 plus 4. Okay. So now we'll get here negative 6 plus 12, which goes down to 6, is equal to, this I'm just going to go ahead and say goes away because that's 0, and so it's equal to 3 plus 4 is 7, so is equal to 7b, and then we divide by, oopsies, sorry, so here 6 is equal to 7b, we divide by 7, divide by 7, so b equals 6/7. Okay, and then same thing for our, to solve for our a. I'm kind of running out of space on this page, but we would do the same thing. We would say negative 2x plus 12 is equal to a x minus 3 plus b x plus 4. Hopefully you can see that. I know it's coming off the page. And then we're going to say let x equal, and this time we want this to go away, so we're going to say negative 4. So see, let an x equal negative 4. So negative 2 times negative 4 plus 12 equals a negative 4 minus 3, and then the b's, I'm not even going to write it because it'll go away because that'll equal 0. And then so we get negative 8 plus 12 equals, again, negative 7a, and then negative 8 plus 4 is equal to 4, equals 7a, divide by 7, divide by 7. So a equals 4/7. So I'm going to take you back up to the top and just kind of write what we figured out. So since we know that our a equals 4/7 and our b equals, what did we get, 6/7, we can rewrite the problem as 1 plus 4/7 over our x plus 4 and plus 6/7 over x minus 3. Now that was taking it a step further than what your book had required you to take it, but I just thought that it might be nice to see like the whole process. But if we go back to here where we just did the division, and this is what we got for our answer, if you were to pull out a negative 2, it would be negative 2. It would equal negative 2 x minus 6 all over x plus 4, x minus 3, and then obviously a 1 plus all that. So that matches the answer that you gave me in the book. Okay, hope it helps.